So heat is the flow of energy. If you have hot side right here and you have a cold side here, energy will always try to balance out. So there's more energy on this side. So energy will always try to travel from hot to cold always. So let's say this is the summer, right? Let's say this is summer. Which side do you think your house is? Your house would be over here. This is the inside of your house. You're trying to keep it cold, right? You maybe have air conditioning, or maybe even not. But the point is, you're trying to keep it cold, trying to get all that from that 100-degree weather outside. You're trying to keep it from coming in. So we need something here. We need insulation to slow the heat, or the transfer of heat, or what they call the transfer of heat. So we're trying to slow that down. We don't want the energy to go over here. It's going to try to. Nature always tries to get everything balanced. So if you have an unbalance, two temperatures unbalanced, it will always try to move from hot to cold, always. And it'll just kind of feed energy. Now, air conditioners are pretty cool, by the way. Just this is a side note. Air conditioners are kind of cool. What they do is they take the warmth in here, even if there's not much, and they pump it back out. It's kind of hard. It takes a lot of electricity to do that. That's why if you ever felt the backside of an air conditioner, outside part where it's outside, you feel hot air coming off that. Technically, it's pumping that hot air is coming from inside your house. It's taking energy from your house and sticking it and pushing it back outside. But what we need is insulation all over your house to try to stop this flow. If this was winter, you would have a wall, and if there was a hot and a cold side, in the winter time, the hot is the inside of your house. So this is the inside of your house right here, and it's cold here, and you're trying to keep the heat from leaving your house, right? It's cold outside, you know, like this maybe in California it's like 50 degrees, right? Fahrenheit. But you know, in other parts of the country it might be 32 or 0 or -2 degrees. It's really cold outside. And how did you get this energy right here? How did you get your house hot? You used wood, you used gas, you used electricity, you used your furnace. You did all kinds of stuff to do that. You spent money, right, on wood or gas or oil or whatever you're using. Different countries use different stuff to warm their homes. But the point is that you spent money on that. This right here, this heat costs money. And money is going to leave and go outside, isn't it? And then you're going to have to put more money to get your house hot again. So you need insulation right here to try to slow that down. If you have good insulation right here, if you have good insulation, then it's still going to leave. There's nothing you can do about that, but it's going to leave slower, and therefore you'd spend less money trying to heat your house up. Okay, so this is very important right here. Okay, insulation in your house. Every house has insulation. If you don't, it would be terrible. Every house has it, just some houses have better insulation than others. It depends what they put when the house was built. So if you go a little cheap and you're like, oh, I'm just going to go with the cheap insulation, and I'm not going to spend that much money on insulation because insulation is kind of pricey sometimes. Well, then you're going to pay for it for the rest of your life, your house. You're going to spend, for 30 years or however long you live in your house, you're going to spend more and more money over and over and over and over again for years and years and years. So really, that insulation is pretty important. It's worth that money, I guess. It pays for itself in the long run, as it does a lot of things. So how do you measure this? When you buy insulation, let me see if I can move this down a little bit. When you buy insulation, it comes with a stamp on it that gives a certain R value. And higher R value, higher R value means more resistance. That's what the R stands for, more resistance. And this is not resistance like electricity resistance. This is heat resistance. So it resists heat flow. Okay? So you want to do a really high R value. Though you're kind of limited sometimes because really high R values are really thick, and not everybody's walls are this thick. Some people's, your wall is maybe this thick, so you only have this amount of room to work with, and so you have to find an insulation that is that thick, and then you're stuck with that R value or whatever. You get the best R value you can for that wall. Some people's walls are thicker. Some people's walls are really thin, only a couple inches thick, and they don't have a lot of choice there. So in today's assignment, it's more about in class. I will tell you, in class we would have had a cool experiment where you make your own insulation and we test it. Okay, I just want to let you know what we would do. You would make your own insulation, kind of go around the school, go around home, and find different cool little things that you can use that are recyclable to make a recyclable like insulation, and we'll see whose insulation is the best by doing some measurements with some heat and like in a little box that holds the heat in, and you're trying to trap that heat in with your little insulation pad that you make. Now we're just going to have to we're going to look at this right here. So here's your assignment: R value and types of insulation, and it says, what is insulation? What is R value? Why is insulation important to homes and businesses? And list a few types of insulation. So I have a short 2-minute video. This guy's really cool, and he explains like really easily and straightforward about what R value really means. And then this one, I found a Home Depot guide that guides home buyers into like types of insulation. They go over all kinds of insulations, and there's a lot of different types. So that's your assignment, and